Hello everyone, welcome back to my YouTube channel. Welcome back to Civil Tech. Here we talk about strength of material, we solve beams of this nature. So guys, if you're just turning in for your first time, to my YouTube channel, you are welcome. Today we are going to solve a beam of this nature. At point A, it is simple supported, and at point B, it is articulated, and we have two concentrated load or 2-point load on the beam that are acting on the beam. From A to F1, we have 2 meters, and from F1 to F2, we have 3 meters. From F2 to F to B, we have 2 meters. So we have a total length of 7 meters. That is 5 plus 2, 7 meters. Now the first question is to calculate the support reactions RA and RB. So these are the support reactions. We have RA, we have RB. So guys, if you are just turning on for your first time, you are welcome into Civil Tech, where we solve strength of materials, we solve beams, and so on and so forth. Don't forget to like, subscribe, and share. So guys, we are going to start. The first thing we need to do is we need to isolate this our beam. We need to isolate this our structure. So we are going to write isolation. So we are going to write isolation. To isolate this our beam, we are going to have this beam, we are going to isolate it in this nature. So to isolate this our beam, we are going to, this is the isolation of the beam. Here it is simple supported. We have RA. At point B, it is articulated, means it has two directions. We have RAX and, here we have RBX and RBY. And we have our point load. We have F2, which is 10 kilonewton, and we have our F1, which is 20 kilonewton. Now we maintain our distances. So here was 3 meters, here is 2 meters, here is 2 meters. So we are going to choose our orientation. Here is the x, we have the positive orientation, we have our m of x, so we have our y. So this is the isolation of the beam. So we apply the principles of static. Sum of external forces equal to 0. What are the external forces that we have there? We have RA, we have plus F1 plus F2 plus RB equals to 0. We now move to the projection on x-axis. When we talk about projection on x-axis, in my previous videos, I have said projection on x-axis simply means forces that act horizontally. And if you look on this our beam, the only force that acts horizontally is RBX. So we are going to have RBX is equal to 0. Now we move to projection on y-axis. So when we talk about projection on y-axis, we simply refer to those forces that act vertically. So on this our beam, we are going to have RA, minus F1 minus F2 plus RB equals to 0. So we make RA and RB the subject of our equation, plus RB is equals to F1 plus F2. So RA plus RB is equals to, our F1 is 20 plus F2, 10. So my RA plus my RB is equals to 30 kilonewton. This is my equation 1. So RA plus RB is equals to 30 kilonewton. We sum F1 plus F2 to give us 30 kilonewton. This is our first equation, because we have one equation and 2 unknowns. It is not possible for us to solve and obtain the value of either of them, of any of them. So what we need to do is you need to move and use the second principle of stacking. Sum of moment of external forces about a certain point, I choose point A, is equal to 0. So the moment of my RA there, my moment of RA here about point A is 0. The moment of F1 about point A is negative F1 into the perpendicular distance from F1 to RA is 2 meters. So the moment of F2 about point A is negative F2 into 3 plus 2, 5. And the moment of RB, now take note, we need to look for the moment of RBX about point A, and in the same way we need to look for the moment of RBY about point A. So take note that the moment of RBX about point A is 0, because if we extend the line of action of this component of RBX, it will come and pass through the center of our moment. So the moment of RBX about this point A is 0. But the moment of RBY about point A is not 0, because the line of action of this our force goes up like this. Are we together? So we have RBY. So we now have plus RBY into 7. It is 7 because we are taking 3, 2 plus 3, 5, 5 plus 2, 7. So we equate it equal to 0. We equate it equal to 0. So we are going to say 7 RBY is equals to 40 plus 50. Why do we have 40 plus 50? We have 40 plus 50 because the value of F1 is 20 kilonewton. The value of F1 here on this our beam, on this our equation is 20 kilonewton. So we took 20, multiplied it by 2, gave us 40. Now when this negative sign crosses the positive sign, it becomes positive. That is why we have plus 40. Now the same for F2. The value of F2 is 10 kilonewton. 10 times 5 gave us 50. Now here is a negative sign. When it crosses the positive sign, it becomes positive 50. So we have RBY is equals to 90 divided by 70. So my RBY is equals to 90 over 7. So 90 divided by 7, I'm going to have 12.8 kilonewton. This is my answer for RBY. It's equals to 12.8 kilonewton. Now, knowing that we now bring in our equation 1. Knowing that RA plus RB is equals to give us 30 kilonewton. We are want to look now for RA. So we are now going to say RA is equal to 30 minus RB. So our RA now will be equals to 30 minus 12.8. So our RA will be equals to 30 minus 12.8. Gives us 17.2. We have 17.2 kilonewton. So guys, don't forget to like, subscribe and share for more videos. So this is how we look for the value of RA and the value of RB.